Hey guys, this is your friend Mainak from Civil Center and I welcome all you back to our channel. And today we'll discuss about the bar bending schedule of our staircase. So before that, we'll study the structural drawing diagram of the staircase, and after that we'll go for the bar bending schedule. So without wasting the time, let's get started. First of all, we'll start with the plan. As you can see, this is the plan of the building and this is the staircase. So if you count the number of risers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 into 2, there is 20 number of rises. So the floor to floor height is your 10 feet, and the length of one particular riser is your 6 inches, and one tread is your 10 inches. So if you do it in mm, it will be 150 mm for the riser and 250 mm for the tread. And as you can see, this particular width is your 3 feet plus 3 feet plus 2 inches. So it's 6 feet 2 inches. That is the width of the landing. So we have to find out the BBS of it. So for that, we'll come back to the structural drawing and see what the lengths are given. So I have taken this. Let's check the. So this is a section of the staircase. So in the section of the staircase, you can see this is the landing, and this is the rise, which is 150, and the tread is your 250. And if you look at the structural drawing of the staircase, as you can see here, so this is a section of the stair, the landing, and in the landing we have a 12 bars, 12 bars at the spacing of 175 center, both at the top and the bottom, uh, both along both the spans. It is the same spacing, and we have rings here. This rings also of all the rise is also 12 rings at a spacing of 175 center to center, and this particular rings, as you can see, this rings is also 12 12 at the rate 175 center to center. And again we have this 3 bars of 10 which is along the longer span. So along the longer span we have 3 bars of 10 2 pairs in every riders. So we need to find out the bar bending schedule of it. So before starting, let me tell you one thing. When we usually go with the staircase, we usually cover the staircase or take the staircase from inside the wall. So if this is the wall, the staircase will go inside. So we can add 250 that is the thickness of the wall, with the staircase while calculating the BBS. So let's get started. A simple Excel program we have made for calculating the BBS here. So the thickness, as you can see, thickness of you can write all the things here. Thickness, that is this, as you can see, this thickness. This is the thickness 150 Thickness of the slab is 150 You can just type here thickness. You can modify it to slab thickness. 150 and length of the steps, as you can see, this is 0.91. So 0.91 is actually 3 feet, which is the length of the steps. And here the riser is 0.15, as you have seen in the drawing, and the tread is 0.25, and landing is 1.88. Landing, you can that's the conversion of 6 feet 2 inches. If you convert 8 into as you can see, this is 1.88. So this is the landing. And next we have number of risers. Number of risers in each flight is 10, which we have written here, and the length of the landing. So the length of the landing is 1.88, which we had already now covered that. So let me delete it from here. Okay, I've taken something, so let it be there. Okay, so these are the things which you have taken. Now for the starting, the place where the structural part of the staircase will start, we need to have a beam here. So this is the landing, but when it will start from here, that is, if you're going from here, we'll need a beam here. So for that particular beam, we have taken your starter beam, and we have taken 10 bars, 4 number of 10 bars, number of member 1, and the length we have calculated like this. We have calculated 1.88, that is the total length here, and after that we have calculated here 0.25 minus 0.02. So 0.25 is your wall width, so we are going inside the wall here, and minus 0.02 is your cover. So minus 0.02 is for your cover from one side. So if you want, you can take this, reduce this beam span also. You can do this divide by 2, because you'll need the beam up to that portion only. So you can do this, divide this by 2, because there will be only one stair to climb, so you can just divide it by 2. So this is the starter beam, and then you can also, this one is this particular hook length. So this one is the hook length, this one is the total length available for the beam, and this one is the particular portion of the beam which will start from here. If it ideally, if we just divide this, I'm just for showing you, if we divide this into 2 parts, so this for the, up to this part we are giving a beam here, or else if you want you can take the entire portion also. Let's give the entire portion also, you can give one beam. So if you want to give in the entire portion, just take the entire length, and we are taking the the hook length, and you can multiply this hook length, this 0.1 into 2, because it will be L shape in both the sides, so both sides is discontinuous. So what we can do is you can multiply it by 2. So how did we arrive at this hook length? So what we did is 0.15 is the thickness of the slab and minus 0.03. So cover of the slab, minimum cover of the slab is 15 mm. So 15 plus 15, 30 mm. So I have deducted 30 here, and here we have deducted the thickness of the beams. That is, we have 10 mm beams here. So 2 beams of 10 mm, that is 20 mm. So into 2 you can do here. So it will be 0.2. So this is for the hooks on both sides. So the shape of this will be like this. Actually, it will not be S1. Let's do this as S4, and you can insert a shape, change the shape here slightly. It can be like this. You can change this and also increase the weight just to make it look visible. Okay, so like this you can do. So this is the particular length of the cut length of this particular bar. So we have 4 number of bars here. Total length will be this number of bars into the cutting length. Total length of bar in all members. We have only one beam, so one member, and this will be d square by 162. D is the diameter of the bar in mm by 162 gives the weight in kg per meter. The total weight is your unit weight into the total length. So like this we can find the number of rods required for the starter beam, and next for the ring 1. So which thing we are taking as ring 1 here? The ring, this particular reinforcement layer, which will be along the placed along the longer span, and this will be our ring 1. So the length, the bars which will be used here is 12 mm bars, as you can see, 12 mm bars for, let's check here, this one, 12 mm bars, and the spacing will be 175. So 12 mm bars, number of bar. So here you can change the number of bars. So number of bar will be obtained by the total length available divided by 175. So total length available here is 0.91. Since the length of a particular step is 0.91, so total length available divided by 175 spacing, and we use the round up option command to increase it by 1. So this will give the number of bars which can be available. Now number of members. So in each flight we have 10 risers. So in each riser we have this one particular ring of this, like this, of 12 mm bars at the rate 175 center to center. So this is 20, and the shape is S2 like this. So this bar will go like this, and it can bend from like this, and this can also bend like this. So it is the shape of it. And the cutting length, you can calculate the cutting length. This is simple. The cover of the slab is 15, but here we are taking as 20 cover, because in practical considerations, if you go for 15 mm, then you need the aggregate, this aggregate of size 15 mm downgrade. So it's better if you take some precaution of 20 mm cover in slab, then it is better in the site aggregation. That's why I've taken 20 mm cover. In the earlier also, where you have taken 20 mm cover, we can take 15 mm cover we've taken, you can make that 20 also. Okay. So this is 0.15 minus 0.04. So what is 0.15 here? So this is the main thing. So this is 0.15. So if you check this up to from here to here, that is, if I can just exactly show you. So this particular line from here to here, this is 0.15, and from here to here, this is 0.15 plus 0.15, this is 300. So we have a rectangle of 150 to 300 here. So we are this subtracting the cover of 20 mm from both sides. This 20 mm from a single side and multiplying it by 2, that gives the total length. So here we have the total length and we are adding 2 into 10 into D. 0.001 has been used for converting from meter into mm, and D is your diameter of the bar. 20D is for this particular extra, hooks which we have to provide like this and like this for the lapping. So for this we have taken this 20D, and after that the total length and the remaining things are similar. Total length is the cutting length into number of bars. Total length of bars is number of members into the total length. Weight t square over 160 total weight. So like this we have for the total weight of ring 1. Similarly, if you check the ring 2 also, everything will be the same, but as you can see here, the ring 2 number of members will change. So we have 20 risers, or we have 10 risers in each flight. So for every 10 risers we have 9 treads. So for 2 flights we have 18 treads. So here the number of members will be 18, and the calculation for the number of bars will be similar. That is the total length available 0.91 divided by 175, and round up 0 increases it by 1 number. And the cutting length of bar will also be the same, because in this case, as you can see, this is 150 and this is 150 plus. So here we have to look. So here, as you can see, what will the cutting length? So this from here to here, it is your 250. So this is 250 plus this 150. So total, if you can add this 250 plus 150, it will be equals to 250 plus 150, it will be 400. So this total is your 400 and this is your 0.150. So just what you need to do in the cutting length, this 0.15 is okay, and here we'll just do this as 0.4, 400, and this will give the cutting length of this ring 2. So the cutting length of ring 2 has been done, and after that we can simply find out the total length. So the total length will be your cutting length of the 1 bar into the number of bars, and the remaining also there is the same program which has been used. So ring 2 also we have done, and after that we have the longer span. So what is along the longer span? As you can see, this is the bar along the longer span, as you can see here. This is the, not this one actually, this one. So we have 3 bars of your 10 mm, 2 pairs of 3 bars of 10 mm in every riser. So what we did is, we can do this number of bars as 6, diameter of bar as 10, number of members as 20, there are 20 risers, and the cutting length of the bar, you can simply, what you can do, you can add the length by plus 0.25 for going inside the wall and deduct the cover from it. So while doing this, you can find out the number of bars along the longer span, and after that you can find the total length of the bar. So the total length will be the cutting length of bar into the number of members, and the remaining programs also will be the same, as you can see here. So now we have calculated the bars in the staircase. Now let's come to the landing. So in the landing, as you can see, the structural drawing is very simple. Here, as you can see, 12 mm bars at the rate 175 center to center, both along the longer and the shorter span, both along the, the top and at the bottom. So that's why I have written here longer span, top plus bottom. So the number of members is 2. Actually, the landing is 1, but since it is top plus bottom both we are calculating, so that's why we have written 2. Number of bars is equals to 6. So how that it comes? it is the total available length of the landing. So the total length of the landing, as you can see here, now the total length of the landing available in the longer span will be the shorter span. So if the bar is being placed like this, so it will go along the shorter span. So that's why you are taking the length of the shorter span divided by 175, and it will be actually the same for the longer span, and for the shorter span it will be the opposite, that is we'll take the longer span, that is the total length of the landing. So that's why you've taken this landing length here. So we'll just have a spelling mistake here. We'll just do this as your shorter span. So like this we'll do, and we have like this we can find the number of bars. So number of members already we have discussed. The cutting length. So the cutting length will be simply the total available for the longer span, the total available length plus 0.25, that is for going inside the wall, and minus the cover of 20 mm on both sides, that is 40 mm. Okay, and the remaining programs will be the same as above. That's the beauty of MS Excel. Once you do the programming, the calculations comes automatically. Similarly, for the shorter span, the cutting length will be your this particular length of the steps minus the cover, and plus you can add your 0.15, that is the particular thickness, minus the cover into 2. So let's see how it is done here. So if you just look into the structural drawing for the shorter span, this one is the shorter span, the bar will come like this and it will go like this. So the total available space is 150 mm. So that's why it is 150 minus 0.04, that is the cover, 20 mm on up, 20 mm bottom, 0.04 into 2, that is on this side also and on this side also. For both the sides, the shorter span bar will remain a hook, so that for the binding. So that's why this is used for at both along the top and bottom. We have used this particular bar shape will be like this. So the bar shape will be S1 actually. S1, if you can draw here or here, as you can see, or you can just write S4 also. So the bar shape will be like this, and that's why we have calculated the cutting length like this into 2. So the total length will be the same here, and the total length of bar in all members will also be the same. Calculation is the same, and we get the total weight. So now if you want to get the total number of bars which has been used, as you can see, 13 pieces of 10 mm bars and 26 pieces of 12 mm bars are used in this staircase. So now you can order at the site after you have done all this. So how to do that? Simply you have used the sum command to add all the, as you can see, for the 10 mm bars, so there is 2 10 mm bars of 10 mm, added this and multiplied this by 1.05, that it will increase the quantity by 5%, and number of pieces you have to use the roundup command, and then divided the total number weight divided by the unit weight of the 10 mm bar into 12, that gives the weight of 1 bar. So the total weight divided by weight of 1 bar gives us the total number of pieces. So similarly we have done it for the 12 mm bars as well. So friends, you also try by yourself to calculate the bar bending schedule of a staircase and let us know in the comment section. So that's all for today. This is Mainak signing off. Keep learning. Bye bye.